Hello, explorers of the cosmos. Ever looked up at the night sky and wondered, are we alone here? Today, we're going to dive into the scientific search for life beyond Earth. Our universe is a vast place, almost unimaginable in its scale. To begin to understand, think of the Milky Way, our own galaxy. It is full of stars, dust, planets, and mysteries. Now, in the Milky Way alone, there are an estimated 100 billion to 400 billion stars, and each star can be a sun for its own planets, moons, and possibly life forms. And the Milky Way is just one of billions of galaxies in the observable universe. Try to imagine the almost infinite number of stars and worlds out there. But amid this vastness, the question arises, on how many of these countless worlds could life actually exist? That's what we want to find out. The search for extraterrestrial life is not just a whim of scientists or science fiction fans. It is a fundamental question that touches the heart of our very existence. Why are we here? We are alone. Over the years, we've defined specific criteria to identify the places most likely to harbor life. The habitable zone or golden zone around a star, for example, is where conditions can be perfect. Now, planets that fall within this zone have the potential to host liquid water, a key ingredient for life as we know it. Water is the magic molecule, the universal solvent that can give rise to biological processes. And as we comb the cosmos, we're not just looking for signs of microbial life. Imagine entire civilizations, societies that, like us, look up to the stars and wonder about their place in the grand scheme of things. Life as we understand it leaves traces. Not just biological, but also chemical and even electromagnetic. When we talk about looking for life beyond Earth, we are often referring to these clues, these little clues that nature can leave behind. One of the most fascinating ways to detect life is through biosignature. These are chemicals such as oxygen or methane, which in certain concentrations and contexts may suggest the presence of biological activity. However, not all biosignatures are definitive proof of life. For example, methane can be produced by geological processes, so scientists look for a combination of gases that together point most strongly to biological activity. In addition to biosignatures, we are also looking for techno-signatures, signs of advanced technology. These can range from space megastructures to intentional radio signals. And as we dream of direct messages from advanced civilizations, it's important to remember that finding microorganisms on distant planets would be a monumental discovery in itself. It would mean that life is not a fluke, but a constant in the universe. Perhaps the simplest forms of life are the most intriguing of all. Imagine discovering microbial life on a distant planet. This would not only increase our understanding of biology, it would also redefine our perspective on what it means to be a living being in this vast universe. It might seem like a daunting task to find life on such a minuscule scale, but science has its ways. One example is the search by extremophiles in Earth's hostile environments, such as hot springs or deserts, to understand how life can survive in extreme conditions. This understanding can be applied in the search for life on moons like Jupiter's Europa, or on planets outside our solar system, the so-called exoplanets. These celestial bodies could have underground oceans or toxic atmospheres where, believe it or not, simple life forms could exist. And it's not just scientists who are fascinated by this. The sociocultural impact of such a discovery would be immense. Religion, philosophy, and even our own ethics would have to be re-examined in the light of a universe now confirmed to be inhabited. So the next time you look up at the night sky, think of the billions of worlds that are out there, and consider that somewhere among those stars and planets, life in its simplest form might be taking place, making this universe not only a space of matter and energy, but also of life. In our search for life beyond Earth, we can't just look anywhere. We need to focus on where conditions are most conducive to life as we know it. And this is where the concept of habitable zones comes in. These zones, also called Goldilocks zones, refer to the regions around a star where the temperature is just right. Not too hot, not too cold, allowing liquid water, an essential ingredient for life, to exist. So far, we've identified many exoplanets in the habitable zones of their respective stars, each one with its own characteristics and peculiarities, making them interesting candidates in our search for life. But being in the habitable zone is no guarantee of life. A planet needs to have a suitable atmosphere, a magnetic field to protect against harmful radiation, and ideally a dynamic geology that can recycle nutrients. The complexity of life, as we see it, is inextricably linked to the cosmic dance of elements, energy, and the right conditions. And as we look for these conditions elsewhere, we are also reminded of the rarity and beauty of life on our own planet. If we're looking for life beyond Earth, how exactly do we do it? The search for extraterrestrial life is a combination of patience, technology, and a lot of interdisciplinary science. One way is by listening to the universe. With radio telescopes, we try to detect signals or transmissions that might be evidence of advanced civilizations. Another strategy is to study the atmosphere of exoplanets. The presence of certain gases, such as oxygen or methane, in specific proportions may suggest biological activity. The quest also includes studying moons in our own solar system, such as Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. These celestial bodies have underground oceans that could harbor life. What's most exciting is that we're not just looking for Earth-like life forms. We are open to the possibility of totally different forms of life that challenge our current understanding of what life is. One of the biggest challenges in detecting extraterrestrial life is communication. Suppose we find an alien signal. How do we decipher its language? How do we send a message back? One of the biggest challenges in detecting extraterrestrial life is communication. Suppose we find an alien signal. How do we decipher its language? How do we send a message back? Furthermore, the language and culture of an alien civilization would be radically different from our own. Creating a universal dictionary for communication would be a monumental challenge. Some proposals suggest using mathematics and physics as a universal language, as these are constant throughout the universe. We could transmit primary sequences or representations of atoms and molecules as a starting point. Ultimately, our quest for interplanetary communication reinforces the idea that despite our cultural and linguistic differences, all of us, whether from Earth or from distant worlds, yearn for connection and understanding. As we search the cosmos for signs of life, a potential guide is the Drake equation. Formulated in 1961 by astrophysicist Frank Drake, it estimates the number of civilizations we could come into contact with in our galaxy. The equation considers several factors, such as the rate of star formation, the fraction of stars with planets, and the likelihood of intelligent life developing on those planets. However, the Drake equation has many unknowns. Recent exoplanet discoveries and studies on habitability broaden our understanding, but there is still much to learn. Some argue that, given the vastness of the universe, life is almost certain to exist somewhere. Others, looking at the apparent lack of evidence, wonder if we are truly alone or if civilizations tend to self-destruct before advancing far enough to communicate. Ultimately, the search for extraterrestrial life confronts us with profound questions about our place in the cosmos and the fate of all intelligent civilizations. We would be on the brink of the most monumental discovery in human history. And you, what do you think? Are we alone in the universe? Thanks so much for exploring this cosmic question with us. If you like this video, don't forget to give it a like and subscribe to the channel for more science adventures.